In this lesson, we will continue with the graphs of the exponential function and its inverses. We will explore some of its properties and discuss what we see. In the diagram displayed, we have the graph of fx, we have the inverse function of that graph, and we have a graph of g. Fx is equal to the log of ax, so the function is a log graph. Then this would be the inverse of that graph, and g is the reflection of the inverse of f in the x-axis. Before we discuss the properties of this graph, let us discuss what we see. The log graph and the inverse graph is the reflection of each other over the y is equal to x line. Meaning, for all the coordinates on the inverse graph, I would swap the x and y's position of the original graph. Then g is a reflection of the inverse function. Now, it's a reflection over the x-axis, which means I have folded or projected the inverse function over the x-axis. It is a mirror of that graph. The first thing we can do out of the diagram or the information given is solve a in the function. Fx was given as log ax. And I also have the coordinate of 32 and 5/2 on the graph of f. This is enough information for me to solve the value of a. I simply replace fx, which is in the place of y, with 5/2. Then I have log a, and x is 32. Remember that fx is interchangeable with y. In order to find a, I can reverse the log. So I can write it as a as the base, 5/2 as the exponent, equal to 32. In order to find a alone, I can say multiply the exponent of 5/2 with 2/5. This will create an exponent of 1, or a standing alone. So 2 times 5 is 10, over 2 times 5 is 10. 10 over 10, which will give me 1. 32 can be rewritten as 2 to the power of 5. So if I do the same with 32, it's the same as saying 32 to the power of 2 and 5. Or 2 to the power of 5, and I multiply that exponent with 2/5. What will happen here is that the 5's will cancel each other out, and I have 2 to the power of 2. Therefore, a is equal to 4. And fx then is equal to log 4x. That is now the equation of f. Now that I have the equation of f and I have solved the value of a, I can find the inverse function's equation. So to find the inverse function, I start with the equation of f. And we are going to follow the 4 steps that was explained in previous lessons. So I replace fx with y. Then, to find the inverse function, I swap x and y's position. And then, to find y alone, I reverse the log. So 4 in the base of the log becomes 4 as the base, and then x becomes the exponent, and y becomes the answer. And then lastly, we rewrite y as the inverse notation. So therefore, the equation or the formula of the inverse function is 4 to the power of x. So we have fx as log 4x, and we have f as 4 to the power of x. Now that I have the equation of the inverse function, I can find the equation or the formula for the reflection of the inverse function over the x-axis, which is g. To find g, I start with the inverse function. The inverse function is given as 4 to the power of x, or I can rewrite that as y is equals to 4 to the power of x. And when we reflect over the x-axis, here's the x-axis, and when we reflect over the x-axis, the y values would change. So the positive values would become negative values. So in order to find g, the y values would become negative. And in order to find y alone, we simply multiply or divide with -1. Therefore, gx is equals to -4 to the power of x. So what we have learned now is that gx is equal to -4 to the power of x. And notice in the reflection over the x-axis that the x values are reflected, they are mirrored. But the y values change from all positive values to all negative values, and that is where that negative comes from. We can also discuss the domain and range of every graph. Let us start with fx. The domain refers to the x values and the range refers to the y values. If I start with the domain, looking at x, I see that the x values for this graph exist only for positive values of x. It will never go left of the origin. Therefore, where x is equal to 0, it is considered to be an asymptote of the log 4x graph. If it is an asymptote, it means that this graph will never cross this point or touch it. So therefore, x goes from 0, not included, up until the graph will exist for all values of x that are positive infinitely. So up until infinity. Another way to write it is x is between infinity and bigger than 0, not equal to, because it will never touch that graph. We can also write it as x is bigger than 0, and we don't have to write infinity, because infinity is an undetermined value. So these are the 3 ways in which you can write the domain. You don't have to write all 3, you simply choose the one which best suits your preference. Now the range is the y values. And this graph of fx will exist for all values of y. Even though it looks like this is flattening out, it is slightly increasing and it will continue to increase forever. So on the y-axis, for every value of y, I will have a value on the graph. Let us see if we can find the domain and range of the inverse function. What you need to know about the domain and range of the inverse function is literally what we have learned up until now, that the x and y swap positions. So x would be all real values. If I look on the graph, I can see for all real values of x, I will have a value in the graph. So the graph will exist for all real values of x. And the range would be bigger than 0. The graph of the inverse function will only exist where y is a positive value, meaning above 0. This graph is never below the x-axis, so always above 0. And the domain and range of the reflection around the x-axis, you would see that this graph, because we reflect it over x, it has the same properties as the inverse function from which it is reflected. So if I look on the graph, I see for all values of x, the graph will exist. But the range, the y values, are all negative. They're always below the x-axis. And the way we write that is always below the x-axis. So always negative. And this shows you what the reflection does. It didn't change the x values if I reflect over the x-axis, but it does change y from positive values. Remember, bigger than 0 means positive, to negative values. And this is a reflection over or in the x-axis.